I would like to introduce Bruno Romero from HP, application engineer, HP 3D print Iberia, Barcelona.
So thank you very much. My name is Bruno. I'm coming from HP. I'm part of the Department of Applications Development team in the 3D business. I would like to show you how the digital manufacturing is getting into the automotive industry. First of all, I would like to introduce to you some kind of drivers and challenges that the automotive customers or stakeholders are finding in the business, and why these challenges are pushing them to adopt what is the 3D printing. So if we go one by one, the first thing we know that the development cycle is getting faster and faster and shorter for all the companies. Now, for the companies in the automotive industry, they are getting, let's say, shorter times to develop products, and in time there are more similarities with the, let's say, the consumer goods, consumer electronics than the 100 years ago automotive traditional companies. Also, we know that the businesses for the companies in the automotive industry is changing. Right now, there are many new businesses running. For example, the share of cars are, right now, there are not that many people that are, or end customers that are proud to buy a car, but they are more than sharing the cars with other peers. We know the case of Uber, Cabify, BlaBlaCar, and so on. We know also that there are many regulations that are pushing to the customers in the automotive industry to change the way they are producing parts or components. We know that the plastics are right now in the spotlight because we have these issues with the microplastics in the weather, so we need materials that are recyclable. Also, we have all these issues with the climate change, so we have to reduce the emissions of carbon dioxide to the atmosphere. So these manufacturers, OEMs in the automotive industry, they need to produce, let's say, cars that are more lighter than the ones that are produced some years ago. Also, we are seeing there are many advances in technology, more focused in the software side, also in the mechanical side, but from the software and firmware side, there are many new applications that are putting inside of the cars. And now there is getting a lot of traction and changes in cybersecurity in the automotive industry. So we know that this is also something that are pushing to these kind of companies. Related to the previous one, we know that many years ago, the software was not a key strategy line of investment in the automotive industry, but right now we know that most of the investment that the stakeholders in this business are put in this kind of business, that is in the software side, because there are many devices inside of the car that should be controlled by a CPU. So this is a key point. We know that there is also new competitors in the market, new companies that are coming from, for example, other businesses. We know all Tesla, Google, they are coming more from the software side or from the electrical vehicle side, and they are changing the way that these companies are approaching to the final end customer or the buyer of the cars. Right now, they don't rely on dealership to sell cars, but they are selling directly from web pages. So this is something, another change that are pushing to stakeholders to change. Also, we see that many end users or buyers of cars, they are looking to buy cars, or they decide to buy a car when they see different electronic components inside of the car, like a big size a screen with a full color, or different devices inside. And it's not that important to have the best performance of the engine or other aspect of the car. So this is also a big issue. The supply chains, now we want to produce what I need, reduce the waste, reduce the transportation of the components from one side to another. So we are changing what is the distribution way, or the supply chains of these companies. And now also we are getting the customers or the end buyers more engaged with the stakeholders, because now they want to get more and more parts that are personalized inside of the car. In the past, we had only the possibility to change the color, to change the wheels, and a few things, the leather inside of the car, but right now the customers expect something extra. So this is also something to take into account. Virtual inventory, we know that the spare parts is a key problem for all the automotive industry. So in the future, what we want is to remove all the spare parts, or most of them. So this is something that is also important in this industry. And the last one is also the lightweight. That's to say, we are trying to produce cars or vehicles that are lighter to get motors that are less powerful and reduce the emissions that we are getting from carbon dioxide. This is also a key point. If we summarize everything, all these drivers and challenges, opportunities these stakeholders are having, we see that all the players in the business are moving to 3D printing or digital manufacturing because of that, because of time. So we have to develop cars or components in shorter time. We are looking for an economic advantage because we are looking for shorter long runs, shorter runs of production. So we are looking for a different break-even point compared to traditional manufacturing, that's injection molding. Performance, we have to reduce the weight of the parts. Now we are coming with the software of topology optimization to get lighter and lighter components. So this is also a key point for additive manufacturing. Personalization, because all the buyers are looking for it, to have a personalized component. And the last but not least is the sustainability, also a key point. When we are looking to the applications, we also approach in HP with the life cycle curve, and we see that in the short term, most of the companies are looking to prototyping, jigs and features, tooling as a way to adapt additive manufacturing. But we see a potential and a need in the real production line and also in the spare parts at the end of life. If we see what is the advantages or the value proposition that's bringing HP with the technology metal jet and multi-jet fusion, they see that we have the fastest technology in the market to produce parts. We have the one that produces parts at the lowest price. Also, we have high-quality components with quasi-isotropic properties. We have now a process control to get all the parts with repeatability and robustness inside of a certain accuracy range. And also, all our machines are scalable to produce more efficiently and adapt to the production that is expected. When we are talking about prototyping, what the customers are looking at is to have parts that are really similar to the end parts that they are going to produce with traditional production size. We have the opportunity to do components that are quasi-isotropic. We can do fine details. We can post-process all the parts, and we can get components that are really similar to the ones that are to be produced at the end. When we are talking to jigs and fixtures, what we are trying to get is the cheapest components as possible for the for the industry. So in this case, what we are getting for the customers or the challenges that are facing to us is to get in production as fast as possible of these tools, these system pictures, not to expand the time to produce them, to reduce the inventory, and also increase the ergonomy for customers. I saw you a video of a component that is produced for a tier 1 company in the automotive industry that is a rubber end of tool to grab some components. So like this. Also, when we are talking about final parts, and this is the end of my presentation, we have a real good case that we like to share. That is a part coming from the BMW, a car that is electrical vehicle, a high-end product. It's not a luxury car. And they show the potential to produce real components, final components. You can look for this video that they have in YouTube, how they produce these components for the parts with our technology. That is quite interesting to see how they are installing these components that are installed in the doors of the cars. And you will see now in a picture at the end. That's it. Oh, there is the component. This is the i8 car. And just to end, only 2 messages. We know that we are in a transition from prototyping to real final production of parts with 3D printing and digital manufacturing. We have this case from BMW that is a real case that is present in the YouTube. But also we have many other cases, and I will be happy to share with you any deeper insights that you want to have. Thank you very much. So.